Welcome to section B.4, solving rational inequalities. So we just got finished up solving rational equations. Now let's take a look at inequalities. So to be able to solve a rational inequality, it's very similar to solving the equation. You're going to solve the same way actually that you solve a rational equation to get your solutions. And then you're going to divide up a number line by the solutions and the restrictions. So we also have to look at what those restrictions are. And then we're going to test each section that the solution and the restrictions give us. So let's take a look at a couple examples here. So 2x minus 7 over x minus 5 is less than or equal to 3. So once again, we're going to multiply. If we can factor, we need to, but in this case we don't have to. We're going to multiply by the common denominator. So we'll take this and multiply everything by x minus 5. And so once again, to write this out so that you can see everything that's happening, this term gets multiplied by x minus 5. There's only two terms, so not a whole lot here, but then 3 gets multiplied by x minus 5. And so on the left side, the x minus 5s cancel, and you're left with 2x minus 7 is less than or equal to 3x minus 15 once you distribute. And then when you solve, you could subtract 3x, add the 7 to the other side, and then divide by -1. And really the inequality doesn't matter. I can rewrite this as an equation. I'm just looking for what that solution is. So in this case it is 8. We also want to know what the restriction is. The restriction is x cannot equal 5 because x minus 5 cannot equal 0. So just like that second step said, divide the graph by solutions and restrictions. So I'm going to create a number line over here. And I have my restriction at 5 and my solution at 8. And so what we want to do is we want to test points. So I'm just going to pick a number to the left of 5. I always choose 0 if I can. So this is where I would test the point 0, or x equals 0. And then we test a value of x in between 5 and 8. Let's just go with 6. And then something larger than 8, so we'll go with 9. And we're going to plug these numbers back into the original problem. So I tested x equals 0, plugged it in, I got 7/5 is less than or equal to 3. Is 7/5 less than or equal to 3? Yes, that's true. So all values to the left of 5 are true. 5 is an open circle because it's not included, it's not part of your solution. So now let's move on to the next section. We're going to test x equals 6. So at x equals 6, I simplified everything and got 5 is less than or equal to 3. Well, 5 is not less than or equal to 3, so this section is false. There are no solutions between 5 and 8. And then 8 was one of our solutions, and since 8 is equal to, that will also include 8. And then we will find out if the next section will have solutions. So we're going to test x equals 9. And then at x equals 9, is 11/4 less than or equal to 3? Yes, that's 2 3/4. So yes, it's less than or equal to 3, so therefore this section is true. So now we have to write our answer. We want to write the answer where all values of x satisfy this inequality. So we're going to go from -infinity to 5. 5 is not included. It's actually a vertical asymptote. And then it's false between 5 and 8, so we'll do the union, and then from 8, 8 is included because it is equal to, x is equal to 8, and then everything greater than 8, so 8 to infinity. So in the end, these are your solutions for the value of x. Alright, we're only going to look at one more of these, made it a little bit more challenging, more stuff going on, so if you want to give this one a try, or at least go in steps as we go through this, go ahead and pause the video and try it yourself. Alright, here we go. So we are going to start by factoring because we have a quadratic that needs to be factored. So it looks like we get x plus 2 and x minus 1. You notice those same factors occur in the other two fractions. So we're going to multiply everything through by the common denominator of x plus 2 and x minus 1. And I will once again show all of my work. So 3 divided by x minus 1 is being multiplied by x plus 2 times x minus 1. The greater than or equal to, I'm just going to put equal because it doesn't necessarily matter. We do need to pay attention that it's not equal to when we go to do the solution though. And so then we will get x over x plus 2. That's the original, and then we're going to multiply that by the common denominator. Once again, x plus 2 and x minus 1 minus, and then you have your x plus 8 over, I'll write it in factored form so you can see those canceling out, and finally multiply by the common denominator one more time to get this. And so now what's going to happen? What cancels? Well, the x minus 1 cancels. So you're left with 3 times x plus 2. Once again, keep this in brackets just so you can see everything. The x plus 2 cancels. So that's x times x minus 1. So that's that second fraction. Minus the x plus 2's and the x minus 1 cancels. So you're just left with the numerator of x plus 8. And so let's distribute and solve for x. We get 3x plus 6 is equal to x squared minus x. Make sure you distribute that negative when you're subtracting that entire quantity. The whole thing gets subtracted. So it looks like we will get a quadratic, x squared minus 2x minus 8. And then go ahead and set it equal to 0. So I'm going to subtract the 3x, and I'm going to subtract the 6. And it leaves me with this quadratic to solve. That'll be x minus 7, x plus 2. And so we get solutions of 7 and negative 2. So also, what are our restrictions? Well, x cannot equal 1, and x cannot equal negative 2. So let's take a look at that. We're going to create a number line with our restrictions and our solutions. Now, one of our restrictions and our solutions happens to be the same. So we have negative 2, 1, and 7. So now you need to test every single one of those 4 regions and see if they are solutions or not. And so I plugged in x equals negative 3, and you can probably do a lot of this on your calculator, but I went ahead and did everything by hand here, and it looks like we have it false in this region. Negative 2, even though it's considered a solution, it's a restriction. Here we have an open circle at negative 2. And so now I'm going to test the next section between negative 2 and 1, and I'm going to test at x equals 0. So when I plugged in 0, I got negative 3 is greater than negative 4, which is true. So this region between negative 2 and 1 is true. X cannot equal 1. That's one of our restrictions. So that will be an open circle. And then we want to choose a value between 1 and 7. I'm just going to choose x equals 2. So after plugging in x equals 2, I got 3 is greater than negative 2, which is a true statement. So between 1 and 7 is also true. I did find a mistake on my x equals 0. So just to go back and look, I had minus, and it should have been minus a negative 4 here. So let me fix that. So it was actually 0. I forgot the minus right here is y. 0 minus, and then 8 divided by negative 2 is negative 4, which would have made this a plus 4. And so is negative 3 greater than 4? And negative 3 is not greater than 4. So that one should have been false. So hopefully you caught that mistake, but I did catch it before I finished. So we have false in the first section, false in the second section, true between 1 and 7. So now we have one more to check, greater than 7. So I will do x equals 8. And so x equals 8 gives you 3/7 is greater than 4/7, which is false. And at x equals 7, it is open because, remember, in the originally it was only greater than, it wasn't equal to. So we don't have any closed circles. Our restrictions never have closed circles. The solutions do sometimes, but that's if it's equal to, greater than or equal to, or less than or equal to. So it looks like what we have is everything in between 1 and 7, but not including 1 and 7. So our final answer, after all that work, is all x values between 1 and 7, parentheses on the 1 and the 7. So that finishes solving example 2 of a rational inequality. Definitely a lot going on there. You have to solve it just like normal, but when you have to set up that number line, that does add a little bit of work. But what I would suggest possibly doing is, as I did all this kind of showing you what plugging in, you can plug those into the calculator and identify what those solutions are, maybe a little bit quicker as well.